How to fix unexpected output voltages in digital to analog conversion. Imagine turning a digital switch and getting a voltage that's not quite what you expected. That's a common challenge in digital to analog conversion. Let's explore how to fix those surprise voltages and get your system running smoothly. Unexpected voltages in digital to analog converters often happen because of errors like offset errors, gain errors, linearity issues, or mismatched components. Offset errors are when the output isn't zero even when the digital input is zero. This can happen if internal resistors or capacitors aren't perfectly matched or if temperature changes affect component values. Gain errors are when the slope of the output versus input curve isn't exactly right, making the output higher or lower than expected across the range. Linearity errors cause the output to deviate from a straight line, leading to distortion, especially at mid-range inputs. Variations in resistors, capacitors, or current sources inside the DAC can also cause inaccuracies. To fix these issues, start with calibration. Apply known input codes like 0 and full scale and measure the output. Adjust the digital input or the DAC settings to correct offset and gain errors. Calibration helps compensate for systematic inaccuracies. Next, consider temperature effects. Use temperature-stable components or add software routines that measure temperature and adjust the output accordingly. This keeps your voltages consistent even as the environment changes. Power supply stability is another key factor. Use regulated, low-noise power supplies to prevent voltage fluctuations that can influence the reference voltage or output. Proper grounding and layout are also vital. Make sure the analog and digital grounds are separated and connected at a single point to avoid ground loops and interference. Using high-precision resistors and capacitors with low temperature coefficients reduces mismatches and drift over time. Filtering the input and output signals can help reduce noise and overshoot, ensuring the output settles correctly. Always verify that the reference voltage is accurate and stable, as it directly impacts the output voltage. If your system allows, digital error correction algorithms can be used to compensate for known nonlinearities or mismatches by adjusting input codes or applying lookup tables. Different types of digital to analog converters, like R to R ladder or current steering architectures, have varying susceptibilities to errors. Choosing the right architecture for your application can reduce issues. In embedded systems, combining hardware calibration routines with software corrections is common. For example, a microcontroller can run initial calibration sequences, measure errors, and then apply correction factors to digital inputs before conversion. By systematically identifying the source of unexpected voltages and applying these corrections, you can significantly improve the accuracy of your digital to analog conversion. This results in more reliable and precise analog signals, making your electronics projects perform better and more predictably.